Ever wondered how to make your Python code more efficient and reusable? Today we're talking about functions in Python. Picture functions as diligent little workers in your code. Their job? To carry out specific tasks. The beauty of functions is that once they're defined, you can summon them to perform their tasks whenever needed, without rewriting the same code. It's a bit like having a chef on call to whip up your favorite dish on demand, instead of cooking it yourself every time. Functions not only make your code more efficient, but they also make it cleaner and easier to understand. They're the building blocks of good coding habits. But what does a function look like? How do you define it and call upon it when needed? Stick around as we dive into the world of Python functions. Now that we understand the basics of functions, let's explore how to define and call a function in Python. Defining a function is as easy as using the def keyword, followed by the function's name and parentheses. A function is like a little worker in your code, doing a specific task whenever it's called. For instance, a simple function greet can be created to print hello. Here's how it's done. Def greet. Print hello. Now how do we call this function? It's simple. Just write the function's name followed by parentheses, like this. Greet. Python will then execute the code inside the function, and you'll see hello printed on your screen. But what if we want to greet someone by their name? That's where parameters come into play. Parameters are pieces of information that you can pass into functions to make them more dynamic, like this. Def greet name, print, hello, plus name plus. When you call this function with a name, greet, Alice, it will print, hello, Alice. Functions become even more powerful when they can send information back to the caller. Let's learn about the return statement. The return statement in Python allows a function to send data back to the caller. It's like a courier delivering a package back to the sender. When we define a function, we can use the return statement to specify the result we want the function to deliver. For instance, a function named add takes two parameters, a and b, and then returns their sum. When we call this add function with the numbers 3 and 5, it returns 8. Now let's discuss default parameters. These are preset values for function parameters. They come into play when no argument is provided for the parameter while calling the function. For example, we have a function greet that takes one parameter, name. But we can set a default value for name, let's say stranger. So when we call greet without any arguments, it prints, hello stranger. But what if we don't know how many arguments a function will receive? Enter *args. In Python, we can handle an unknown number of arguments in a function using *args. Imagine you're writing a function that adds together any number of arguments. You don't know beforehand how many arguments there will be. This is where *args comes in handy. The asterisk before the variable name args tells Python to collect all remaining arguments into a tuple. Here's how it works. In this function, args is a tuple that holds all the arguments passed. The function then iterates over the tuple and adds up the values. So, if you call, it will return. Now let's shift gears and talk about lambda functions. These are small, anonymous functions that we define using the lambda keyword. The term anonymous means these functions don't have a name. They are concise and useful when you want to perform a small operation without the need for a full-blown function definition. Here's the basic syntax of a lambda function. In this example, x is the argument, and x*2 is the expression that gets evaluated and returned. This lambda function takes a number x and returns its double, so if you call, it will return. Both *args and lambda functions are powerful tools in Python. They can make your code cleaner and more efficient. However, in programming, it's not always about brevity. Sometimes we need more complex structures, like when a function needs to call itself. This is where recursion comes into play, but let's save that for the next scene. Lambda functions are concise and convenient, but sometimes a function needs to call itself. This is where recursion comes into play. Recursion is a concept where a function calls itself to solve a problem. In the world of Python, recursion is like a Russian nesting doll. One function houses another identical function, which in turn houses another, and so on, until we reach the smallest doll, the base condition. Think of recursion as a way of breaking down a big problem into smaller, bite-sized pieces. It's like taking an enormous pizza and slicing it into manageable portions. You deal with one slice and then the next until the whole pizza is consumed. Let's illustrate this with a classic example in programming: calculating factorials. A factorial of a number is the product of all positive integers up to that number. For instance, the factorial of 5 is 5 times, 4 times, 3 times, 2 times 1, which equals 120. In Python, we can create a recursive function to calculate this. Here's how it looks. Here's what's happening. The function calls itself until it reaches the base condition, which is when n equals 1. At that point, it stops calling itself and starts multiplying the numbers as it unwinds. If we call, it will return. Recursion can be a tricky concept to grasp initially. But once you get the hang of it, it can be a powerful tool in your programming arsenal. It's especially handy for problems that can be divided into smaller, similar problems. But remember, recursion must always have a base condition to prevent it from going into an infinite loop. That's it for today's exploration of functions in Python. Remember, functions are your friends. They help you write clean, reusable code and make your programs more organized and easier to understand.